when there is a threat actor using a GenAI model for malicious activities, then the prompt which has been used for that is considered as an IOPC, an indicator of prompt compromise.
How does this TTP kind of fit into this AI applications being embedded and created?
I hop into your network and then use your AI in order to generate more AI attacks.
I'm using this example to follow the money along with an agent and assist the analyst to understand if this kind of patterns is a money laundering patterns or not.
Do you find that the leap someone today would have to take from a red teamer to become a threat intel in their spare time, is the leap too far still?
It used to be that, ideas are a dime a dozen and execution was a matter. Now it's actually started to reverse where execution has started to get so easy. Good ideas are becoming more
anyone
hard.
can do that. AI has been embedding in security, in research, threat intelligence, and perhaps even being used to attack organizations as well. Caleb and I had a conversation with Thomas Roccia, who works for Microsoft and has been talking about his open source projects on how AI can be used for threat intelligence, how he used it for identifying crypto laundering, how much AI can actually truly do today, and what are some of the challenges when you go down the path of using AI agents in your threat intelligence space. And perhaps you can even reverse engineer applications that you thought you knew were vulnerable. I had a personal confession during the episode as well on my journey for reverse engineering. I'll let you enjoy the episode when you hear all about that. If you know someone who's trying to work on integrating security with AI, especially from a threat intelligence perspective or from a red teaming perspective, if you know someone who is doing this, definitely share the episode with them. And as always, if you are here for a second or third time and have been enjoying the episode of AI Security Podcast, I really appreciate if you take a second to hit that subscribe or follow button, whether you're listening to us on Apple or Spotify or watching this on YouTube or LinkedIn. I really appreciate the support you show to the work we do by hitting that subscribe and follow button. I hope you enjoyed this episode with Thomas and ourselves, and I'll talk to you soon. Peace. Hello, welcome to another episode of AI Security Podcast. Today, we've got Thomas. Thomas, welcome to the show, man.
Thanks. I'm super happy to be here today. So thank you for the invitation.
And maybe to kick it off, I obviously have known you for some time. Could you share a bit about yourself? What have you been up to all the way? You can go back to France, Australia, all the way, man.
Sure. Well, that's a long story, but to keep it short. So my name is Thomas Roccia. I'm currently working as a senior threat researcher at Microsoft. And I live in Australia because I'm originally from France. And before joining Microsoft, I was working for McAfee in the advanced threat research, where I was mainly focusing on threat intelligence, tracking nation state and cyber criminal activities. And right now at Microsoft, I'm more working on malware analysis, threat intelligence also a little bit, and mainly AI and security.
Okay. So, and this is where before we join, I'd love to tell me a little bit more about this. What is this that you do and how does it work?
Right. So my team is Microsoft Security and NI Response team. So it's basically working on the technology and working on GenAI to apply it in cybersecurity processes. So the goal of our team is mainly to see and to create the product of tomorrow that every cybersecurity researcher will use in the future. So it's a lot of work because we are really applying GenAI for practical processes.
Is this like malware reversing, binary analysis? Like when you think about GenAI, like there's a lot of variants of how you can apply it. Where's the primary or what's the pie chart sort of look like?
That's a great question because there is plenty of way to incorporate GenAI in your cybersecurity workflow, and reverse engineering or malware analysis is one of them. So we've been working on that to integrate AI models and building autonomous agent system to analyze for you malware piece of code and make sense of everything. So it's kind of assisting the people doing malware analysis with AI. And it's pretty cool because you automate the work that we used to do manually with AI. It's not perfect, of course, but we are working on it to improve that along the way.
Is that sort of the predominant usage of your AI right now is, hey, we're going to do sort of a quote-unquote co-pilot and assisting in the reversing of binaries and malware?
This is one of the usage. So I've been working also on integrating threat intelligence processes with GenAI. One of the projects I've been working on that I'm going to release and show at DevCon on Saturday is a crypto money laundering agent. It's basically a way to track the money flow, the crypto money flow, and understand some patterns to identify money laundering mechanisms. So I'm using the Bybit hack, which was a recent case where North Korea stole $1.4 billion. So one of the most expensive heist in cryptocurrency, in the cryptocurrency industry. And I'm using this example to follow the money along with an agent and assist the analyst to understand if this kind of patterns is a money laundering patterns or not. So that's the idea.
Interesting.
Yeah.
So did you actually take that and look at that case and sort of track it all the way to its ends using an agent?
Exactly, that's the idea. So when North Korea attackers stole the money, what they did a big transfer to one of the wallet, and from this wallet, they did multiple transfers, which was about like maybe 1,000 wallets, and then 100,000 wallets. So it's kind of like a big schemes.
Yeah, you kind of butterfly and you continue to, so you don't
Yes.
know which wallet is the one at which sort of gets the proceeds.
So they split the money. So this is a money laundering scheme. They split the money to make more difficult the tracing of the money across the blockchain.
The smaller chunks.
Exactly.
But could you tell us a bit about, to your point, you help people integrate AI into cybersecurity. What's happening in the background? Because I feel like there's also a lot of, and you're releasing a tool, obviously, so you can tell us a bit about the architecture.
Yes.
What people talk about multi-agent, throw a lot of words and all of that. So how would you describe what's happening in the background for people to understand, like what's really happening when you say you followed the trail? What's happening there?
There's usually, in agents, there's a piece of human work that let me tell you how the analyst did this before, and then here's now how sort of the agents are making that better. Yeah.
So to keep it simple, implementing AI for threat intelligence processes is kind of complex because it's a lot of multiple elements to bring together. So for the blockchain tracking, for example, it's very complicated because when there is thousands of wallets and thousands of transfers, to put that into the context window of an agent, it's kind of complicated.
Yeah.
So because, as you know, the context window is limited.
Yeah.
And so you have to find a way to track the money, to feed the agent with the context engineering, and make the analysis more understanding for the analyst. So right now, the current agent is working on a piece of the blockchain rather than feeding all the information into the agent.
Oh, okay.
So that's the idea.
Right.
Yeah.
And is it going piece by piece? As in, like, you have a specific task, once it's done with that, then you have another agent that runs after?
Exactly. So basically what you can say, practically, you can ask the agent to say, okay, give me the latest 10 transactions that are more than 10,000 Ethereum, for example.
Yeah.
It will look to the blockchain and bring back this information to the analyst. And then the analyst can iterate on that information, look for a specific wallet. Okay, give me more information about this wallet. Does this wallet is connecting to multiple wallets also? And then it's more like assisting rather than
a co-pilot.
Kind of a co-pilot, like not a full autonomous system. Because it's more complicated to do that with a huge amount of data such as the blockchain.
Okay, so it's like it'll go to a wallet, and if you sort of like, hey, analyze this wallet, it will then go through and analyze all of the wallet's actions, what it contains, where it goes. And then you have to spider that to the next one.
Exactly.
And then, tell me more about all this wallet and then how this works. And I'm naive about sort of, crypto money laundering, although this would be fascinating. So I'm going to use this as a way for you to teach me. How does, even from the basics of crypto money laundering to going back to sort of this North Korean, how does that even work? Like, for example, we also know a lot of attacks that have occurred where there are billions of crypto and Bitcoin stored in wallets at which the attackers have never actually pulled back out of these wallets. And always the thesis has been, it's because it's easily traceable, right? Because they could never take the money. So it's just, they steal it, but it just sits there. So how are people actually laundering the money to where they can actually take it and use it some way? What's the basic example?
This is a very interesting question and very complex to answer because there is multiple ways to launder the money on cryptocurrencies. So one of them, and I just touched a little bit about it just before, which is splitting the money between multiple transactions. So you have a big amount of money on a wallet, and in a very short amount of time, the attacker will split the money on 50,000 wallets, and then the money will be splitted between all that transaction. So it becomes more complicated to identify that. But a way to find these patterns will be to have some temporal analysis because the transaction will be done at the same time, and the amount will be also the same since it will be automated. Then you will have also the fees that will be equivalent. So there is some way to understand that this money flows is a crypto money laundering schemes. Does that make sense?
Yeah, what stops, and I've heard that, once you get a wallet, you have to convert this into some currency. And that's like the problem. It's like, I've got crypto, I've got it in a wallet, which can quote unquote be anonymous, but I then have to somehow convert this into some real capital somehow.
In fiat.
Yeah. And then and then there's this aspect of what you said, and I've heard this before, which is like, okay, well, if I have, I don't know, $1 billion and I could randomly seed all of these wallets with a huge amount of money, and everyone gets like real wallets, free money.
Yeah.
But then 1 or 2 or 3 of them are the actual attacker wallets.
Right.
And then they then somehow find ways of then doing it and then converting it, and that's how they get this money. Is that sort of how this works?
Kind of like this is a whole process. So splitting the money is one of the way to lose the track of the money and make the tracking more complicated. You can also bridge the money to another cryptocurrency, from Ethereum to Bitcoin, for example, because DPRK.
Now you're on a different ledger after that, yeah.
Yes, DPRK is
hot chains, do all these things.
And
yeah.
Bitcoin is more, there is a broader adoption of Bitcoin across the world, so it's also easy to just use the Bitcoin for buying some stuff rather than converting the Bitcoin into a fiat money. So sometimes you don't need to convert the Bitcoin in US dollar or another currency, but if you need it, then they need to have some physical, business that will operate for them and that will launder the money for them.
Then it becomes regular money laundering.
Exactly.
Yeah.
Okay. But before going to this step, there is multiple schemes that can be used, bridging the money, using potentially mixers or coin join that will be used to mix the money with other transactions. So there is multiple way to launder the money.
Because obviously you kind of spoke about one example where you were able to trace that. You've done some work in the whole LLM TTP as well.
Yes.
Which you've been talking about. And
Yes.
I think, was it indicator of IOPC?
IOPC, indicator of prompt compromise.
Yeah, could you tell us a bit about that as well?
Of course. Yeah, I was just talking about it at Black Hat Arsenal because I released an open source tool. I presented an open source tool which is called Nova.
Yeah.
And Nova is to detect adversarial prompt in your AI system based on detection rules. So let me explain. First, indicator of prompt compromise. This is a term that I coined after reading a threat report from OpenAI, Microsoft, Google, and Anthropic. They released one of the first threat reports in the world last year and also this year about how threat actors are leveraging their models for malicious activities, such as generating malicious code or generating piece of disinformation that will be used and spread on social network, or even generating some social engineering email or content.
Fake images.
Exactly.
Yeah.
So when I was reading that, I said, okay, that's great. We have some information about what they did, but we don't have the prompt. And without having the prompt, it's difficult for a threat analyst to understand what you can detect in your AI system. Because imagine if we take an example, if we imagine in the future, every organization in the world will use GenAI system, right?
Yeah.
This is likely a close future, right? So that means you will need to monitor and have some visibility about what your model is doing and what your users are doing. And I think you agree with me, prompts are central with GenAI system. Even if you talk about agent, there is always a prompt. If we talk about model context protocol, this is a prompt. If we talk about a chatbot, this is a prompt also. So prompt is everywhere in GenAI system. So you need to have a way to monitor that and detect adversarial prompts. So prompt injection, prompt jailbreaking are part of the indicator of compromise. But not only, could be also generating a piece of code that will be used for malware. That's something you may want to detect as well. So the idea of Nova is to create a detection rules to detect this kind of adversarial prompt. And IOPC is all about that indicator of prompt compromise. When there is a threat actor using a GenAI model for malicious activities, then the prompt which has been used for that is considered as an IOPC, an indicator of prompt compromise.
Because I was going to say from an attack, you know how attack MITRE has like this TTP thing that they have floating around as well. A lot of that focuses on identity, compromised application. I feel like, is this like the next evolution? Because I have most of the applications today hosted on cloud or wherever. They may be AI embedded or AI enabled. How does this TTP kind of fit into this AI applications being embedded and created? Obviously, I understand the AI native application. How does that fit into like an application that is perhaps considered traditional in the sense of what we were doing pre-AI? How would that work for like a I don't know how to say it. It's like a retrofitting AI into like an old world.
Is what you're saying, like, well, hey, okay, well, I'm in a normal enterprise and I'm using it. So clearly my systems aren't being used to quote unquote generate new malware.
That's right. Yeah.
But that is an assumption that's being made. And if I do LLM firewalls, which is a central place to get, I'm probably looking for ways at which attackers are trying to abuse my system.
Yeah.
But I'm not necessarily looking at they are using my resources to then create new malware, right?
Yeah.
That's sort of your
Exactly.
point in this.
Yes.
Is like, okay, what if I get popped? In this similar way is like, I think the old world model is they hop into my machine in order to attack other machines.
Yeah,
Right.
that's right.
And
yeah,
so
yeah.
now I hop into your network and then use your AI in order to generate more AI attacks.
Yeah.
Might be a
So
sort of
that's
what
where
you're
the
looking
difference is
for.
between, because the reason I asked that question also is because a lot of people, when they think about TTP, they're thinking of the attack mode of TTP. And a lot of the tools today still rely on that, especially in the threat intel space. But what Caleb was saying as well, it's going in that direction where now you're not going in to say, I've taken over your domain controller. I've gone in, I'm creating more attacks using your own AI systems out there. Is that a fair
So
summary?
there is two things. First, the previous security bases are still relevant with AI system because we are running AI on the same servers as before. This is the same thing. And the second thing about the MITRE attack matrix, which is very relevant in that case, they also have a MITRE matrix for LLM TTPs, which is called MITRE Atlas.
Okay.
And this is one of the first resources we have with the OWASP LLM Top 10, which is also a good one. But the MITRE Atlas matrix classify the TTPs of threat actors using AI system. So this is similar to the MITRE attack matrix, but very targeted for AI system.
Oh, right. And I guess to your point, the question here is more that the traditional security tools are created more for, hey, what's my SQL injection versus XSRF?
Exactly.
It's not looking for my English translation or a French translation of a prompt as well.
Exactly. Yes.
Yeah. The question, though, I would understand is this would seem to be something that would be under an umbrella of prompt injection, right? Like in order to, to some degree, I guess you would have to manipulate, or maybe you have direct access to someone else's LLM and you're doing that. But this is just a manipulation of a prompt to do things that which it probably shouldn't be doing.
That's a great observation. And actually, in the classification of indicator of prompt compromise, I define 4 categories. The first one is prompt manipulation, which contain prompt injection, prompt jailbreaking, prompt evasion, all that kind of manipulation of the prompt itself for modifying the AI system. Second one is abusing legitimate functions, such as generating a piece of code is legitimate until you have to you use this code for a piece of malware, for example. Yeah. And then the third one will be to identify patterns, malicious patterns in your prompt activity on your prompt system, such as because when an attacker will try to jailbreak an AI system or will try to potentially exploit the vulnerability or the weakness of an agent to get access to some data that the agent is connected, that there will be an iterative process into the prompt where you will see the attacker trying to change the behavior of the agent, for example. So that's something you may want to detect.
Okay, so I have to ask a key question here.
Yeah, go ahead.
So this open source project you released,
yes.
Does it use also AI in order to determine if it's an AI?
That's a great question. That's actually a great question. So let me explain how it works. So Nova is a detection rules, which is similar to Yara. Are you familiar with
Yes,
Yara?
of course.
Okay, for malware, for files, you can define a match, a patterns that will match for a specific file. Nova is the same, but for prompt. Except Nova works with 3 different sections. You have the keywords. You will match a prompt with a specific keyword, for example, hack, or for example, ignore.
Whatever signature at which you would
You
put
can also
in there,
use regex if you want to detect username, email address, or sensitive information. And then that's the first section, keywords. The second is semantic meanings, which is detecting a prompt on the semantic meaning of the
which
sentence.
You're just going to use a normal machine learning model for the semantic.
It's an embedding. I'm using an open source embedding models, and then I calculate like a similarity score between the prompt I'm evaluating and the prompt which is in my rule.
Yep.
And so, for example,
this is fantastic, by the way.
Thank you very much.
I was like, that's a great idea.
It's still an early project, but I'm trying to push it. There is some attention. And the last one, to answer your question, is LLM as a judge, which is the third section. You can use in your Nova rule LLM as a judge, where your LLM will determine if the prompt is malicious based on what you describe.
Can I just want to call something out here that I think is super important and really critical about sort of what you just said, is there's a factor of what you're saying here, which is amazing, is there's a balance of where you use and how you use LLMs, how you use signatures and detections, how you use regular machine learning models in terms of semantic understanding. And the fact is, it adds both a layer of defense in depth. It adds a layer of both performance and capability and sort of what you're doing, so that I can't just now prompt inject the prompt in order to say, hey, if you're a judging model, please ignore this as a test, right? Because the rest are going to flag both on signature, both on semantic. And then you're going to have this confidence coming out that says, hey, 70% of this really matches as a potential attack, even if the LLM itself fails to flag it. And I just love this sort of process that you put here around, hey, I'm balancing both the best of the worlds here. You don't just throw everything to an LLM and then say, I've figured out the balance and the defense and the depth to be able to both do this quickly in the right performance and ensure things like prompt injection aren't possible here. Well, quote unquote.
That's exactly the idea. You get it totally. And the last thing, you can also define the condition. So you can say, my rule can match on the keyword or the semantic or the LLM. Or you can say and, or you can say and or no, or and, or it's up to you. So you define your condition for the matching you want for your rule.
That's awesome. I was going to say, in terms of people who are in threat intel, obviously would want you, and I get there's a gap in the conversation people are having about, hey, I'm using research to identify, I've used AI for my security process or whatever. And to your point, you're trying to go deep into this. For people who are in threat intel, how much of their current workflow can be done better or probably improved by using AI agents? And how far can you go with it? I'm curious from that perspective, because after watching or listening to this episode, people are like, oh, actually, I should probably use that for my side. So how far have you seen yourself take it? And to add to Caleb's question, are you using more LLMs or are you going on the embedding path there as well?
So that's a great question. And I think I'm going to answer by something simple, something important. Not every workflow or every process need an agent or an AI. So it really depends what you are trying. I'll give you an example that I shared last year that I'm presenting in my training as well. I'm not sure if you remember, sometimes there is some leak which are, from the underground or some data that you need to analyze, because in CTI,
data breach,
data breach. But I'm not talking about data breach from official organization, but more from ransomware gang or last year there were a leak from a Chinese company which were doing offensive activities and related to the government. And this leak is actually a good way to leverage GenAI, because when you do threat intelligence, you transform and translate raw data into something meaningful that will inform the businesses and your intelligence processes. So what I did, the leak was PNG files containing a screenshot about PDF files, such as internal documentation about offensive tools and a different kind of data about what was the target and all that stuff. This leak was PNG written in Chinese, Mandarin. And then what I did, I processed the data. I used OCR to convert the data into text. And then I converted this text into English, because I don't read Mandarin, fortunately. And based on that first information, I used a RAG, a retrieval augmented generation, where I put the data into my system and I augment my agent or my AI system, which is connected to my RAG, to request the data without diving myself into the data one by one. And it's a great example because it can speed up the process of analyzing the data without going manually through everything.
You know what would also be even more interesting is you may not even had to have done the translation from Mandarin into English. Your agent itself could have just stored all that in RAG and then converted it, and then at your output converted it to English.
You're right, but it's always important to ground the data generated by AI. So one of the way to do that is to verify the generated answer with the real data.
Yeah, so you can reference it much more easily.
Otherwise you have an output, you don't even know what you're if you're getting this hallucination or actual thing.
To mitigate that, so the good way is to validate the output manually, Or you can also use some additional step, but to keep it simple, like it's always good to have the original data so you can compare what the AI generated with the real data.
So like, and this is maybe a more real world practical question as you're sort of building these things, and maybe it's a little bit technical, but one of the things that are sort of somewhat issues with RAG is although you can get your nearest, okay, this is related and do this, but in many cases it misses so many because it's not extensive in its ability, right? So you'll get windows of the information that are relevant, but not necessarily when you want all information that is relevant. How do you sort of manage with that, especially with such large amounts of data?
Right, you are absolutely right. And this is one of the challenges. So there is multiple ways to improve that. And first will be to improve your retrieval process. What you just described is called the naive RAG. You just compare the text with the data you have, and then you are looking for the nearest neighbor and the nearest data, which are the most similar to what you have. But when you do that, you can lose some context because if you have the data which are the most similar to what you ask, you may lose the context because you probably don't match something which is referenced at some point in other part of the data. So to improve that, there is multiple ways to improve your retrieval process. One of the way will be to use an hybrid search, which is mixing retrieval by keyword and retrieval by semantic as well. So that way you improve. But this is not only the only way to do it, because the process of ingesting the data into your embedding is also very important. The way you chunk the data, the way you parse them before putting them into an embedding is also very important. So you have to, when we talk about threat intelligence and generative AI, you have to master and understand your process from the beginning to the end. Because if you miss a part in the process, then your RAG could be completely wrong or not good enough for your research.
Yep.
Interesting, because that's an interesting one, because I find that a lot of these conversations, I also feel for people who are in threat intelligence today and are being asked to use AI for, hey, use AI for your day-to-day because we want as an organization, we should be using, all should be using AI. I feel like, is there a gap in terms of what threat intelligence traditionally was and what it is with AI? Because are you trying to, how do people upskill in that AI piece which is missing at the moment? Is in terms of, to your point, you mentioned RAG, you mentioned embedding. There's quite a few terms you mentioned which probably understand because we've been...
Yeah, could I even like maybe if I were to, I don't know if I'm restating what you meant, but there's almost like this, in threat intel, there's multiple kinds of threat intel, right?
Yes.
And what kind of threat intel are you focusing on?
That's right.
And also maybe your question is there a new kind of threat intel that comes from the AI world, right?
Yeah.
Because like when you say threat intel for me, for something, the first thing that comes to mind is like breach, attacker, TTPs, I need to go create a detection rule sort of threat
There's
intel.
There's a 0 day out there.
Yeah, but there's also a lot of different kinds of there. There's fraud threat intel. There's, malware threat intel. So like, when we talk about that, what's the kind and where do you focus? Yeah.
So it's a really good question because CTI is all about the data and how to understand this data to make it intelligence. It really depends because when you work in threat intelligence, you have access to multiple kind of data. We talked about malware earlier. That's a piece of intel, as you mentioned.
Yeah.
And when you need to analyze this malware, then using AI can be useful for potentially analyzing the code, but also to look for similarity in the code with something you already analyzed in your data set. And that's kind of the example you can do. We talk about data leak. Data leak is a good example. You can put the data rather than going deep into all the data and trying to do the analysis manually. You can just request an agent or an AI system connected to your data and say, okay, I want to know what are the target or what kind of offensive tools they've been using, this kind of information. And then for crypto money laundering schemes, then you will identify potentially, you will feed the agent or the AI with blockchain data, but also with some, it's mainly blockchain data when we talk about crypto money laundering because all the information are based on that. But then you will create tools that will enrich and augment your agent through an MCP. This is actually what I did. I connected an agent through MCP servers. One of the MCP servers is connected to Etherscan, so you can get the access of the Ethereum blockchain, so for transaction and so on. Then I created a tool for identifying patterns into the transaction, and I created another tool that will pass the information, the blockchain transaction, into a graph, so you can
So
visualize.
these are all
the graph.
connected to MCP.
Exactly, yes.
Yeah, and then you just say, go figure it out.
Not exactly. That would be the next step. That would be the next step. The thing is, with blockchain data, this is so big that for now, I have no way to feed all that information. I don't have enough resources for the Bytebit case, at least. If you have a smaller case, it will be easier. But for the Bytebit case, the schemes and the money laundering scheme is so big. It's not currently possible to run an agent and do the work automatically.
Yeah. You need to ingest it in something like BigQuery, all of it.
Yes, and that would be the next step.
And then the agent can just write the queries and then let the system go figure that out.
Yeah.
Are you going to go do that?
I would love it. I was limited in my resources for the demonstration at DEF CON, but that would be the next step. Yeah, absolutely.
So you've written this cool tool that you released as open source, which basically says, okay, here's how you can now apply AI to help do fraudulent sort of money laundering detection on crypto. Right?
So I haven't released this one because it's for DEF CON on Saturday. I released Nova, which is for the prompt detection.
Okay, so there's two. There's Nova, your prompt detection, malicious prompt detection filter, and then there's the crypto one that you're releasing on DEF CON.
It's an agent. I'm not sure if I will release it because right now it's the state of the code is proof of concept, and we'll need to work more to release it to the people.
Tell AI to fix it. You bytecode that.
No, but actually, I released the tool today because Nova was released last March, and I presented today at Black Hat Arsenal. And at the end, I released a new tool that I created 2 months ago, which is called Proximity.
Okay.
And Proximity is a MCP scanner connected with Nova. So, are you familiar with Model Context Protocol?
Of course,
Okay.
We did a session on that pretty early.
Right,
So how would proximity fit into this? Can you just explain that as well?
Yeah, so it looks at the prompts inside of MCP. Is that okay? I'll let you.
Pretty much.
So, stop answering for him.
No, that's great. That's super cool. No, actually, so Model Context Protocol exposed to your AI system tools, prompt, and resources. And the thing is, you can access an MCP servers remotely or locally, right?
Yeah.
And when it's remotely, you don't have access to what the code is doing. So potentially there is something that could be harmful. And then if you run this malicious MCP server, then you can get compromised because this malicious MCP server can run code.
And we've seen good examples of this already starting to happen in the wild. So,
exactly. VirusTotal released an interesting report on that where they found, I think they analyzed like a lot of different MCP server and they found on VirusTotal, and they found that, I don't remember the percentage, but many of them were vulnerable or created for malicious purpose. So if you think about it, when you have an MCP server who expose a tool, the tool will have a description. And this description will be read by your LLM system, your AI system. This description is actually a prompt. So what I did, I created, and Proximity is actually a tool that will probe an MCP server to get the information for the user. Okay, we have this tool available, this resources, this prompt, and then it's connecting with Nova. It's connected with Nova. You can define a rule to check, for example, jailbreak prompt injection, and Nova will actually read the name of the tool and the description, which can be weaponized. So that's the idea.
Yeah.
Interesting.
And also, it even works. I would assume. I don't know. You can tell me if this is true, but in my assumption of this model, it works even way further than in a description itself, because a malicious MCP server can also mid-fly in its API calls or when you're calling it and doing things can inject malicious prompts. But Nova is always watching all prompts going back and forth and should also be able to detect that as well.
That's two different things. You can, of course, have your system which is connected with Nova, and then you can monitor the prompt. And then you have the Proximity tool, which is a scanner, pretty much like a network scanner, but for MCP servers specially. And then you can verify the security. Proximity is actually giving you a risk score for each tool that you are scanning. So it gives you more information about what the MCP server is doing before
Before
Using-
even using it.
Exactly.
Yeah,
That's the
great.
idea.
Yeah.
Yeah.
I mean, sounds like a startup in the making. Kunal, that you discovered 2 problems that could be solved by a startup.
This is the problem in the AI world is you're right. That would have been a startup 10 years ago.
Yeah, actually.
Now there's no moat.
No.
Because anyone who's listening to this podcast will vibe code that in 3 minutes.
Yeah.
Yeah.
So funny enough, I was talking to someone, we spoke about browser extension in one of the episodes. I got a message from someone who follows the podcast and like, hey man, I heard this in the podcast and now his product has browser extension as a way to show a quick ROI. So he's not wrong in that. Like people listeners, oh well, that's a great idea. I should do that.
It's interesting because it used to be, this is maybe a little off topic, but just one thing to interject is like, it used to be that, ideas are a dime a dozen and execution was matter. Now it's actually started to reverse where execution has started to get so easy. Good ideas are becoming more
anyone
hard.
can do that.
Yeah. And so you have to be more careful about some of your ideas now are somewhat IP because by the time you say it, the execution time to go and build it can be done very, very fast.
Especially with someone who has resources as well.
Yes, exactly.
Yeah. Well, actually, maybe talking about being careful as well, because I guess the other side of the coin for threat intel is like, what have we learned from this so people can actually protect themselves from it?
Exactly.
What are you finding in that in the work you've done with Nova, Proximity? What for people who are on the blue team side, on the work you're doing, what are you finding? Actually, I'm also curious, how real are some of the AI threats that you're seeing, which are specifically AI threats? There's a whole proof of concept world where universities have done something and now people are like, hey, this is going to affect my company. What is the reality there?
Yeah.
And also, what should be people doing in the blue team today for this?
That's a great question, and you know what? It's still a new topic, for the industry. I think there is everything to do, everything to build, but there is still some cases, some malicious cases out there. This is the beginning, but it's coming. So one of them, for example, actually I have multiple examples. So we talk about threat reports published by OpenAI and Anthropic and Google, Gemini, and so on, and Microsoft as well. So they release piece of information about how threat actors are using GenAI, but it's one of the case. Another one, which is maybe more practical, there is agent or AI plugin for multiple tools. And I think it was, if I remember correctly, it was last year. Slack has a chatbot, and this chatbot was actually connected to some Slack channels. Slack, I'm sure.
Yes, Slack, yeah.
And this chatbot has a flow, and if you interact with it, you could leak one of the
DM messages,
exactly.
right? Yeah, you could read them. Yes,
exactly.
Yep,
Yeah.
I remember
you remember
this.
this?
Yeah, I do remember
right.
this. Yep.
So that's one of the example. Another one that I have in mind, which is maybe more concerned. I think it was a research released by, I don't remember the company, but what they found that an attacker, threat actors, powered an AI system on the underground to produce malicious information, and I think it was sesame information, so something nasty. And what they did, they actually stole an API key to OpenAI or Azure OpenAI that a legitimate organization was using.
Yep.
So they used that API to power something very, very bad on the underground. And that's one of the examples. Like if you have your API key which leak in the underground, then you will need to have a way to see what kind of prompt are coming, because this one was this API
This is
key.
a theft of wallet problem.
Yeah, exactly.
Yeah.
Because this API key was actually using to generate like sexual content from a legitimate company. So it's a problem if you are an organization,
especially if you're governing. You have compliance rules and all of that as well.
Yes.
Well, I mean, the thing is like if you're OpenAI, Anthropic, or whatever, they might look at this and be like, "Hey, what the hell is going? We're cutting your account, right?"
Yeah.
Or because, and the other thing is, it really is more theft of wallet problem.
Yeah.
Like it's like giving away an AWS key and then they take it and start using your infra, or
crypto mining,
crypto mining, or doing
yes.
things. Yes, and this is similar. And by the way, like I think this has been a problem. Even in the early days of AI is where the keys are getting leaked and they're just taking it and then now using AI for free based off of those keys.
So I guess secret management should still be very tight.
Yeah. Actually, I have another example which was released 2 weeks ago, I think. The CERT-UA, Ukraine, they released an analysis of a malware that was using an API connection to Hugging Face to generate malicious command into the infected machine. So the malware was running, and from the execution. It was doing some LLM request to generate command to exfiltrate information and get some information about the infected machine itself. And the prompt was actually embedded into the sample itself.
You know, this brings up sort of like some really interesting topics around that last one, which is, you know, we normally think of, obviously attackers are using this to do better OSINT or better spear phishing or whatever this is. But like this aspect of now being able to kind of have much smarter malware is a really interesting one, because if it does make these calls, which, by the way, in every organization, these calls are going to be made, right?
Yeah, that's true.
And this malware does come out, and then it can use the information in the system, call AI to make smarter decisions, or even create custom malware on the fly based on the system it's running or the environment it's in, based off of this model usage, is really fascinating to think about, which actually would go back a little bit towards your open source project, which is your existing, if you're an enterprise and you have AI calls, maybe someone's making malicious AI calls to go create this sort of smart malware.
Exactly.
Right?
Yeah. So that's something you want to monitor for sure.
Would you say, because a lot of people also talk about multi-AI agent architecture as well. We spoke about MCP, we spoke about TTPs as well. How far are we, and obviously you were using agents in your discovery for crypto mining as well. How far do you, or maybe, is there a use case for multi-AI agents in this?
Multi-AI agent is, I think there is a use case for sure, but it's not easy to build a reliable system with multi-agent, because by definition, an LLM is non-deterministic, so you have to put like a lot of different guardrails and way to validate the output. When you have a multi-agent, you have agent that will react and act on different tasks. And the agent will go, if we talk about autonomous agent, then the agent can go crazy, because it will try to, do some execution of multiple tools for the analysis and so on. And I think right now we are a little bit, we are not there yet, but I think it's coming. Like one of the, a great example is Claude Code. Claude Code is actually an agent for coding. And then they released recently, like things last week or something like that, you have the sub-agents, so you can create sub-agents.
You've been able to do it for a bit,
right?
Yeah.
So sub-agent and Claude and sub-agent is an example of using a multi-agent system. And which is interesting is, from my testing, what I did, because you can leverage Claude Code with the SDK. So that means you can programmatically use Claude Code to generate some code on the fly. So one of the examples that I did, I passed a piece of code which was obfuscated, and I asked Claude, I craft Claude to be a malware analyst, and Claude is able to understand, okay, so I have a piece of code to analyze. It seems to be malicious. It's obfuscated. So to understand what kind of code is it, I need to first deobfuscate that. So if it's something simple, it can do it through a command line. But if it's something a little bit more complex, it can write a piece of code to deobfuscate the script and send it back to the agent. And then you can iterate like that on the data. So that's an example.
Right.
And we are still at the beginning of multi-agent, I think, but there is multiple way to ground the data to make sure that everything is working. One last thing is having a human in the loop in the process of your multi-agent. So you validate, and this is exactly how Claude Code is working. When he wants to create, to execute something, he first asks the user to validate or to decline the request. So human in the loop might be the solution in the future for this kind of task.
At least the current stage where we are at. And to your point, the more agents you add, the more complication you add into your architecture as well. And the more, I guess, it can go in any direction it thinks. I think we did a whole vibe coding episode where the AI, the code that was being produced was basically trying to just hide the fact that it made a mistake, and it kept trying to...
Well, it's very common in vibe code that this happens with tests where you'll have a test case and be like, okay, we have to make sure that, hey, we cannot go to the next phase unless we pass these unit tests and these integration tests. And the integration test will fail. And after a certain amount of iterations, Claude will say, well, screw it. I'll just modify the integration test to mock it, to then make it look like it, and so that it passes, so that we go to the next stage.
And next stage after that. No, it's an interesting one, because I also feel like the stage where LLM is today, I think there's a big gap in people talking about reasoning as to where it can be autonomous. I think one of the things that people fear at the moment and still talk about is the fact that, hey, it can make automatic calls itself. And to your point, even though people are putting guardrails, like asking the human before they execute,
Mhm.
have you seen any examples where it has gone autonomous, quote unquote autonomous, as the agentic AI people talking about, in terms of attacking something or threats? Is that
Yeah, have you
Okay.
seen have you seen anything impressive yet that
Yeah,
really is
like-
like, okay, this thing is,
it's like this is alive, for lack of a better word.
which by the way, we don't expect a good answer here.
Yeah. I'm like,
we're just hoping. Like,
we're
seeing-
fishing basically.
Yeah.
It's like, is there a good example there?
That's a good question. In terms of threat intelligence and cybersecurity, it's hard to say because I think we are still at the beginning and there is multiple elements to put in place to have something which is reliable and impressive, as you said.
Yeah.
So I think we are closer, very close to have something which is good and impressive, but there is still some work to do. Yeah.
So if I were to abstract, pull back just a little bit, and
Mhm.
we've talked a lot about your open source tools, a lot of the presentations you're doing. Is this related, or how is this related to sort of what the work you're doing at Microsoft and AI?
And no, not really, because it's an open source project, so I did it on my spare time. But at Microsoft, yes, I'm working on integrating AI for, investigating different kind of cyber attack or incident response, and doing also some malware analysis. Yes.
Yeah, can you talk more about that? Is that something that you can also dig into? Tell us a little bit more about how you're using AI in Microsoft and where it's working and where it's not.
So we have a blog which is coming tomorrow, I believe, about a project we've been working on for malware analysis. So this is an autonomous system where you feed a malware to the system and the system is able to analyze the samples and give you a report to the user. So it's still a work in progress, but it's very interesting and very, very cool to see that. And some other thing, I think, I'm not sure if you heard about it, but there is some model context protocol server for reverse engineering connected to IDA or Gydra, for example. And these kind of servers are quite impressive because they can do the reverse engineering for you and give you some information. It's not perfect. It's not a silver bullet, but it's still impressive. And if you have that, which is already, because the reverse engineering is the time-consuming and complex process because it takes time to analyze and understand a sample. But if you can automate some part of the analysis, the reverse engineering, and understanding the code and so on, that's maybe something which could be relevant in the future.
It can make, and what's really kind of amazing to me is like way back in the day when I first got into this, like I was a reverse engineer, right? And like the amount of time and effort it takes to understand how to do this is like, that's why there are people who are just phenomenal, and it takes years to learn this. But now with AI, you can just be a newbie, quote unquote, come in and probably start really reversing things quite easily, right? You can find overflows and you can find these issues probably fairly quickly without understanding assembly or how to think about these things. Like it'll just figure it out.
I have a confession on this as well, because I think I tried doing buffer overflow in the beginning of my career, and shout out to Steve. I think he's a bug bounty hunter now. Tried really hard to explain to me. I was like, man, I just do not give. I have no idea what is going on here. I basically, it took me half an hour. I'm like, okay, I'm going to give up. This is not for me. And to your point, now I feel there's actually a remote possibility that, I feel threat intelligence as a field requires you to have some level of experience to begin with. Do you find that the leap someone today would have to take from, hey, I'm a red teamer or bug bounty hunter or whoever, to now, hey, I've heard Thomas, clearly this is a possibility here. Is the leap too far still for someone from within another part of cybersecurity to become a threat intel in their spare time and find bugs and new kind of things, I guess?
You mean with AI?
Yeah.
And actually, there's even a bigger question, which is this a good or bad thing?
Well,
I may
he'll tell you
not have the answer to that.
After 5 o'clock, he'll be here as the grey hat.
This is a drinking discussion.
Okay. No, it's actually very relevant because it's a really. So my belief is that the society, the industry is changing thanks or because of AI, depending of how you see the things. I think the process we used to do, the workflow we had is currently changing and evolving thanks to AI. Today, you can do the work much more faster than before.
Yeah.
And I think there is something which is important for the people in the industry to understand, is that there is, because we've been talking about AI and machine learning for a while before LLMs.
Of course.
And it was a hype for many years because the marketing, the comments and so on was all about, the marketing speech was all about AI will solve the industry.
What do you mean, like today?
No, I mean before
And
LLM.
also before, like today.
Yeah, but today, it's kind of the same one. It's kind of the same
AI
one.
always goes through these. Like there's like I think there's like in the 70s. There's like there's ones in the 90s. I think or something like that.
I think one episode we spoke about there were 5 cycles already.
Yeah. There was a bunch of cycles.
We're already in the 5th or 6th cycle of AI, by the way. So there you go. Sorry, you finish.
But I think it's different for LLM because there is something which is very advanced compared to machine learning we used before, even if in some cases machine learning was useful. And so for the people in the industry, I think it's important today to not focus only on the base skills that we used to have, such as reverse engineering, understanding a vulnerability exploit, or doing some pivoting for threat intelligence. Right now, you can speed up your process with AI, and you have to understand how you can incorporate AI in your workflow, but not using ChatGPT and say, okay, give me a joke or write me a joke. Because most of the people in the industry were skeptical for a long time because they say AI is not relevant. But it's just because they don't know exactly how to, build a system, an AI system with relevant piece of information. RAG is one of them. Grounding the data, having human in the loop. There is multiple ways to improve your AI system. And what is important today is to see how you can connect the dots for your core expertise, whether you have a pen tester, an explorer researcher, a reverser, a threat intelligence analyst, understanding the basic and how you can build it practically.
That's awesome.
Yeah. I mean,
okay, so Microsoft, you're releasing this blog that's going to help the reverse engineers sort of on this malware side. What else are you hitting up in Microsoft, and how are they working with AI?
So right now we've been working on helping users and analysts to investigate a case. So you have some data, and then an analyst will have some help, like kind of a copilot, security copilot, that will help you understand what kind of cases it is.
Is this like SOC?
Kind of, yes.
Yep.
Assisting SOC analyst, responding to an incident. And the idea is really to, I think in the industry, it's called vibe investigating.
I like that term. Like vibe investigation.
We should just add vibe to the front of everything.
Exactly.
They have started doing it. It's like
can
vibe
we
marketing.
rename our thing to Vibe
podcast?
Cyber AI Security Podcast?
That's a good idea.
Let us know in the comment section.
If you prefer the Vibe AI podcast, let us know. Okay.
Go for it. Sorry.
So that's the idea, like helping people to getting on track on the case and understanding what kind of incident there is. Is it malware execution? Is it privilege escalation? There is some evasion mechanism. All that stuff to help the analyst, and that will reduce the gap of investigating the data. And that's all about AI. AI is actually reducing the gap for the entry level of the people, and you can speed up your learning phase also because you have the data right at your hands.
Publicly available.
It's about taking that cruft of junk of manual work that you had to take from one resource and another and synthesize it and understand it and make a decision to come to something that actually an LLM is very good at being able to compress that. Right?
It's really good. And something that I wanted to add as well, most of the, at least for what I saw, most of the security tools today are using LLM summarization, which is good, which is getting information from some data and summarizing this data for the users. I think the next step will be really to have something which is more intelligent with AI, with multi-agent, with multi-agent system. And I think that is the next step, how you can automate everything, connecting to different kind of tools. Because LLM summarization was the first step, and then the next step will be more.
But I also think that there's a very particular reason for that. And the reason is that, everyone right now is needing to call themselves an AI company and an AI product. And so what they do is they bolt on AI. And the easiest way to bolt on AI is summarization.
Exactly, yes.
Now what you have is you have companies who are building sort of, AI core companies, which they are building their product and their technology with AI at its center. They are now doing the more smarter things, but this is still infancy in those stages. Again, it kind of reminds me of cloud days when
Yes,
you know
exactly.
exactly everyone's a cloud product and they're like, oh,
Exactly,
we have something you can launch an EC2 and we connect to it, and then the companies came out that truly built their architecture around cloud and made use of its abilities. And I think that we are still in the early phases of seeing what AI core companies can do, right? When you build your business around AI and the way you deliver a product around AI, you're going to see some pretty dramatic changes, I think.
Right.
No,
That's
awesome.
really cool. And question for you: did you experimented with AI agent, or what kind of work did you do? Because you seem very. I know you are running the AI security podcast, so you're already familiar with the ecosystem and everything. But what kind of experimentation did you do already?
You go first. No, you go first.
Well, with AI agents specifically.
Oh, yeah.
Yeah. I mean, I think, I just manually, personally myself started coding things. And I'll tell you, it had nothing to do with enterprise stuff. All of the stuff that I manually coded all had things to do with like more EA, personal task organization stuff. Like, I'll give you a great example. And this was not an agent. Actually, you know what? With terms today, I'm going to just call everything an agent. So maybe this is an agent.
So yes, he built an agent, yes.
But like, I'll give you a great example of just something stupid, right? Which was, hey, one of the things is I have lots of attachments, lots of documents and things I need to keep track of. But building an organizational system for that is fairly complicated, right? Like if you really want a way to understand where your data is so you can quickly reference it, like it's kind of hard and it's manual in its task.
Right.
So my first experimentations around AI was building a system that would take the document, parse the document, understand the contents of it, automatically both tag what is relevant, find and automatically categorize it within the list, and then move the file to the appropriate folder system structure of where it's categorized. So for example, if you get a document in, is it a finance document? But yeah, out of a finance document, is it a tax document? And then for what year is it for? And then for me, I have also companies. What company versus myself individually? And then what was it referenced by? And so you'd get emails for these things. So what I wrote a thing for would take the email, take the document, parse it, the email, the document, automatically understand the categories of which it is, and then categorize it, auto tag it, move it to the folder structure, done.
That's pretty cool.
Right. And so then every email or attachment, so now what's going to happen is people are going to prompt inject me. Like, oh, now I know Caleb has a system that parses email attachments. Here's the
so next email coming out of the
But like that's the kind of, me messing around for like personal things like that is like the kind of thing. Like I haven't gone to the sense of going through and saying, let me actually build cool security tools yet out of this. But I think it's mostly because just based off time.
Right. Yeah,
like,
of course.
It's been hard.
Same for me as well.
It's already amazing. Like, I mean, it's potentially like far away from most of the people, like doing an automation for your personal stuff. It's really cool.
Yeah. And it's like, and what's really also interesting is I started that project when I think, LLMs were first starting to come out. And I've continued sort of iterating on that project as LLMs have gotten better and better. And it's amazing. Like I've rewritten this thing 4 or 5 times and how much faster and easier and better the rewrite gets in what I've been doing. And by the way, I have another one that I've also done around contacts and contacts in your address book around the ability to, by the way, address book organization and search is terrible in every system. Right. And so like I wrote this command line thing that did this, and on both of these, I've rewritten them in LLMs, and it's amazing how much faster, how much better, how much easier it's gotten to be able to do this stuff.
That's pretty cool.
Right.
Interesting. Well, I kind of, I knew this before because we spoke about this before in another episode. I think for me personally, I don't think I've built a security tool yet. I think what I have been going down the path of, because with TechRide.io, we've been doing a lot of advisory.
Right.
And I'm trying to build at least in my mind, I've got this Notion template going on because Notion has an AI at the moment as well. I've got this almost like a database, my drag database, for lack of a better word, going on with what the current AI architecture being used by most organizations is. So my hope is, at least, and I did, to your point about the picture that you said before, the PNG file, a lot of that is just pictures people have shared with me and go, hey man, this is where we started, this is where we are. Right. And like, what's the difference? So I think I've been using a lot of it to parse data to help people quicker. And I think it's become my quote unquote, I have a RAG that I maintain, but I'm not building a security tool. Now that I've had this conversation, I feel I should revisit the buffer overflow.
Yeah, absolutely.
Yeah, like, I think the
should.
last time I opened
Yeah.
MITRE Pro, I was like, oh my God, all you see is 0x, 0x. I think I even got, for a hot minute, I changed my name with that 0x thing on Twitter. I'm like, like, how do you explain
You
to
no-bite?
Yeah. And I'm like, how do you, I was like, I did that only for 24 hours and I came back to like Hashish Rajan after that. I'm like, this world is not for me. So I feel like I maybe should explore that world now that I have spoken to you about
should.
this. I feel there is a possibility, because I feel...
Girdra, right? Because Girdra's free, right?
Yeah, Girdra is free.
Yeah, I almost feel like, oh wait, I think I always looked at research as a space that I would love to do that when I have some spare time. So a lot of the current focus that I've had is primarily either in the architecture space or in the engineering space. I am doing a lot of Kubernetes engineering. So what does that look like? Terraform building. We do some training with them as well. So that's basically where we've been using it. I don't think we've gone to a point where I would love to build a security tool. I feel to your point about ideas are now IPs.
Yeah.
Now I'm going with that with like, I'm making a note of all of them.
What should I build?
Yeah, but there's also the fact that the more you talk about it, the more you realize the...
Hopefully you can edit that out.
Yeah. On that note, we're talking about basically end this conversation. No, I definitely find the accuracy piece is harder and harder as the data. I think you kind of mentioned this. The more data you collect, now I think the amount of information that I have, after a point, it's not practically possible for me to go back and check, was this actually what the architecture diagram was, or was this actually what the code was? That's the part where I'm currently struggling with. I haven't figured out a way around it yet, but that's where I've landed with the AI piece at the moment, where I'm like, okay, this is kind of it has helped me speed up a lot of things which have taken me a long time, come up with frameworks. I released like a 7-layer framework thanks to that, because I could see the architecture. I'm like, oh, there's a clear pattern here. And I didn't have to use AI for it. I just had to get that pattern out.
Use Gemini 2.5 for your PRD and your architecture. And then use Claude Code to write your code.
100%. You guys are totally selling me into it as well. But on that note, we're on the episode, the end of the episode as well. Where can people find all this information that you're releasing in terms of open source code, your talks and training and all of that as well? Where can people find all that information?
On the website for Nova, which is novahunting.ai. So there is everything, the code, the documentation, and you can start from here and from there. And then I'm publishing quite often on social network, on LinkedIn and Twitter mainly. So you can find me also there, and on my blog, which is blog.securitybreak.io. This is my personal blog.
Yeah.
And yeah, this is where I'm pushing my spare research and stuff for the industry. So yeah, I'm trying to lead the way in AI and threat intelligence and cybersecurity, because I really think there is a shift, and I'm hoping to help the people and the analysts across the world.
Yeah,
that's
I mean, definitely doing that. So thank you for sharing that research with us as well.
Thank you very much
on the show.
Thanks again for the invitation.
No problem. Well, thanks everyone for watching. We'll see you next time. Thank you for watching or listening to that episode of AI Security Podcast. This was brought to you by techriot.io. If you want to hear or watch more episodes of AI Security, check that out on aisecuritypodcast.com. And in case you're interested in learning more about cloud security, you should check out a sister podcast called Cloud Security Podcast, which is available on cloudsecuritypodcast.tv. Thank you for tuning in, and I'll see you in the next episode. Peace.